Hey YouTube, so in this video I'm going to be teaching you guys how to do some basic web scraping in Python with a pretty cool and simple library called Beautiful Soup. So if you're not sure what web scraping is, it pretty much tells you right here, a library for pulling data out of HTML and XML. Yeah, that's just a nice way of saying web scraping. But basically, if you can think of any web page that has some data that might be useful to you, this is a good library for extracting that data and creating a Python object that makes it more usable instead of just a giant hunk of HTML. So the first thing I want you guys to do is get yourself set up. This should give you some basic instructions on how to install it if you don't have it already, and maybe even a simple example. But today I want to go through a real-life use case of using this library. Okay, so the example I'm going to be using in this video is a chess opening explorer, and you might be interested in chess or you might not really care about it, but either way, this is a pretty simple example that you can learn and then take on to use it in a topic you might care more about. So just to briefly go over what this is, if you've never seen an opening explorer before, it just shows you a position and then it lists the moves in order of how popular they are. Like this is 1.7 million games played, so on. And it tells you how well each move performs. So it's going to win, it's going to lose sometimes, it's going to draw sometimes, and obviously you want to go with the best percentage. So you can kind of just play moves here, and in every single position it's going to give you an idea of how popular or unpopular a move is and how well it performs. So you kind of get the idea. So if you're somebody who plays chess, you might aim to get an advantage by just studying openings, because if you know that a move is best in a position, even if you've never played it before, or that it's very popular, you know you should either play it or you should study against it. So a really great way of studying openings is proportionally based on popularity. So a great way of doing this is web scraping, writing a program that will essentially take in this data and play a move proportionally likely to how popular it is. So I'll give you a quick example of that. So the program I wrote here is just something I have to import main, and I'll do main.moveTest. And this is going to play a move. So it played the move and it said it's the second most popular choice. So it basically starts in this opening position, it looks at this database, and there's about 1.1 million games here, and that's about 1/3-ish of all games. So there's basically a 1/3 chance of this move coming up. So if I type 1.d4, because I know d4 is the second most popular move, it tells me I'm right. And then it wants to know, hey, what's the most popular response to d4? And I know that is knight f6, and that's correct. So for example, if I were to play d4 on move 1, you'll see that in this position, yes, in fact, knight f6 is the most popular move with around 600,000. So I could keep doing this. d4 knight f6. The second most popular choice against that is, I think, knight f3. Yeah, so you get the idea. And then it wants to know the first, but let's say I get it wrong. Let's say I say this is 2 ... I don't know, f5, which is not right. It's going to tell me, no, you're wrong. Actually, g6 was correct. So if I play through this, you could see, all right, knight f6. We were right that the second most popular move was knight f3. g6 is going to be the most popular move here, which we were wrong. It tells us what the right option was, and then it says game over. And if I were to play this again, it would give me a completely different game, just because it's random, but it's random proportionally to popularity. So if I play it again, we'll see this time we get move choice 3 on move 1, which I know is knight f3, and we get a totally different game just based on random chance. So this is a great way to avoid basically being biased towards openings that you like, or choosing totally random openings that'll never happen. It gives you the best balance of both, so you can study openings to make you most effective against the average person. All right, so now that we know what we're looking to build, let's get into the actual scraping. So the first thing you're going to want to do is use a browser that has basically good dev tools. So I think most people probably use Google Chrome. So if you go to any web page, right click, inspect, it basically gives you this nice view of, as long as you're on the Elements tab, it'll give you a really nice view of the web page here to your left. And as you start to highlight over different parts of HTML, it shows you what part of the web page you're actually looking at. which is really, really awesome. So just by using this tool, you can probably get down exactly to the data you want. So if I scroll down here, I'll see here's all my move data. And I'm basically just going to highlight until I see, okay, it's part of this div. So I'm going to want to go inside of it and just basically mouse down until I see what it's a part of. And it looks like it's this thing called sidebar 2 here. So I'll open that up. And you basically just kind of continue this process. If you've done this before, this is probably something pretty familiar to you, but I can see like, okay, this table here has some data that I want. I'll open up this body and you can continue on basically right up until a single piece of data. So if I look in here, I see this is a row. This is basically one piece of the row, and in here I see the actual text itself. And if you want to test to make sure that you're right, you could change this to, I don't know, let's say 2E4, and you actually see that reflected here. You're just changing basically the HTML that you're viewing in browser. You're not actually you're not actually changing this on the server side, but it basically just gives you confirmation that you found the specific piece of data that you're looking for, and you can go in and out until you basically find every piece of data you're looking for, and that will give you a good idea how to actually scrape for it. All right, so we'll take a quick look at the code now. There's a few imports here. These two are at least pretty important. This is the Beautiful Soup import, and this is basically a helper one you'll need for URLs. Random is just for my specific use case. And then here, I try to define all my constants. The base URL is probably good. This is the extension to go to the Opening Explorer. And then this is an argument you'll need to pass into Beautiful Soup to tell it what you're parsing for. And then the remainder of these are going to be some constants that are going to help Beautiful Soup define basically the parts of the web page that you're looking for. So remember we looked at sidebar 2. I have that defined here so I could find that ID. And then here we have a bunch of helpful HTML tags that are going to basically just help us find the data we're looking for. Things like a div, table, the different row and column identifiers, the ID itself, and then the href is going to help us navigate move to move. So most of this code is basically code specifically for the game. Like you can pretty much ignore this. These are just some tests that I wrote. This is another helper function for my test. Pretty much the entire actual scraping code is in this function here. It's as modular as taking in any URL. Well, basically a specific URL from this website that points at a position, and it returns just basically a list of the moves, like a Python object. So I'll quickly step through this. This is the HTML object. You use URL lib2, pass in the URL, and then you create the Beautiful Soup object. So you give it your HTML object, and basically you give it the second argument, which tells how it's going to be parsed. It's just a string. And then here, the first thing we're going to do is we're going to find that sidebar. So you can use soup.find. Basically all you're doing is you're letting it know, okay, it's going to be a div, and it's going to have an ID of sidebar 2. So these are all constants that are defined, but they're all just strings. Like div is div, sidebar 2 is sidebar 2, ID is ID. Oops. But yeah, nonetheless, this is going to give you the reference to your sidebar. So if we go back into the web page here, you'll see if we find sidebar 2, which I think, here it is. So it's going to give us basically a reference to this specific HTML object. And the reason I use this one is because it's sort of the most specific one that has an ID. If something has an ID, ideally you would like to grab that. But otherwise you can sort of use the children to find what you're looking for. So for example, beyond that, we just want to get a list of all the tables. So you can do find all on table. So there's a bunch of different ways that Beautiful Soup allows you to sort of find the elements you're looking for. You can find a specific ID like we've done here, and then we can use that to sort of find some children, in this case all the tables. And then just looking at the table, I've sort of hard coded that, yeah, it's going to be at index 1, right? That's not a big deal. And then once again, we're going to do the exact same thing on that position table, and we're going to find all the TR. That's basically the rows in the table. We give it this, it's going to give us back basically just a list of rows. And now here what we're going to do is we're going to loop through those rows, and we're just going to pull out the data that we're interested in. So we're going to instantiate this move dictionary, and then we're going to find all the TD, which is sort of like the column parts of the rows. And then we're going to do some work to extract out the href and the move itself. So if you do something like .a, that's going to give you the move and href object, basically one beautiful soup object that contains both. And if you do simply get text on it, that's going to give you the text itself. So we care about that. And if you use basically index of href string, it'll give you the URL suffix. So we're going to use that to essentially navigate through our moves. So if I go in here and show you that a little bit more closely, here's the href. This is the URL, which you do index of href, and get text will give you the text itself. So if you ever have something that basically has an attribute here, but also something in between the tags, that's how you access both of them. And we're interested in that to know what the text is and also be able to navigate from move to move. And then here I basically just need a little try except in the case where you go too far and you can't actually navigate another move further. But essentially this is just going to give us our games number. So it's going to pull the column list. I just know it's the hard-coded index 1, and all I need is get text. And it just so happens that the failure is going to occur when I attempt to cast it to an int, because sometimes this might be something wrong just based on the website. But nonetheless, we basically craft all these together, we return our move dictionary, and then we use this in our tests up here, like the one I showed you earlier, and it allows us to sort of parse through. We do some simple math. This is basically the function that uses the random variable. It just adds up all the positions, picks a random index, and chooses one based on the likelihood that you would get it, given that it's proportional to the popularity. And here's a separate test. Well, this is the one I showed you, move test, but index test is essentially the same thing. But instead of you choosing the right move based on the index, you have to choose the right index based on the move you're given. So it's a little bit easier, but essentially the exact same thing. So basically, if I had to give you a general strategy for whatever website you're trying to scrape, I would say whatever data you need, basically try to find the most deeply nested object that has an ID. In our case, it was this sidebar. And then to get whatever you're looking for, you basically just use children until you find the data that you need. So with that being said, you'll notice there's a decent amount of hard coding going on here, like knowing exactly what index it is or exactly how many rows you might expect in a table. So with that being said, there's a reason that web scraping is called scraping, and that's because it's only going to work given the proper state of the website, or possibly into the future depending on what the developers do, if they update it or how maintainable their updates are, because technically tomorrow whoever the developer for this website is could release an update and this could totally change and then the scraping wouldn't work anymore. So to give yourself the highest likelihood that your web scraping will continue to work in the future, you want to try to make it as least arbitrary as possible by sticking to IDs, but in some cases you sort of can't and you just have to use whatever index the object you're looking for is. All right, so that's basically my full explanation of the code. If you want to look into it a little bit more deeply, I'll put the link to the GitHub in the description. The rest of it should be pretty straightforward, like writing the game, taking input, and calculating the probability. But if you have any more questions on that, feel free to leave a comment in the description and I'll get back to you. So yeah, hopefully this video was useful to you guys. If you want to see more content like this in the future, consider subscribing. And like always, please like, comment, and share if you think other people would be interested in this video as well. Thank you guys for watching.